Example 2, let f of x equals x cubed minus 3x squared. Find when these weird looking things, and then sketch the graph of y equals f of x. So let's look at these complicated things for a start. This is saying the list of x values, or the set of x values. This symbol here is the derivative. And then we've got less than signs, and we've got 0. So the first one is saying what are the list of x values when the derivative is negative, because it's less than 0 or sloping down. This one is positive or sloping up. And this would be for stationary points. And then we have to sketch the graph. So first things first, we better find the derivative, and then accordingly search for all of these things. I dare say the stationary points will probably be the quickest and easiest thing to do first. So we found the list of x values for when the derivative is equal to 0. Now what we need to do is to find out when it's positive, where it's negative, and I would suggest using the stationary point table. So much like in the previous example, all I need to do is to substitute into the derivative the values -1, 1, and 3 to find the nature of these turning points, or stationary points. We don't know if they're turning points, but this nature of the stationary points. So our two stationary points, the one when x equals 0 is a maximum, or a local maximum, and then the one where x equals 2 is a local minimum. So therefore we can use this to our advantage to identify where the graphs are positive, have a positive gradient or not. So for AI, the list of x values when the gradient is less than 0 will just be this section here, in between 0 and 2. So for the values of the graphs where the derivative is positive, then for what we need to do is we'll have to have two sets here. So it looks like it's all real numbers except that small interval. So I'm just going to write it accordingly. Please take care that you note which brackets to use. It's all real numbers except the interval of 0 to 2 including, because at 0 and at 2 is when it's flat. So therefore it has to be all the other numbers. It has to be greater than 2 and less than 0. Now we just need to sketch the graph. So we found our x-intercepts by making the original graph equal to 0, and we know that one of them is going to be at 0, 0, which is also the y-intercept and also one of our turning points. And then we've got an x-intercept at 3, 0. So we just need to know where the minimum point is, that when x equals 2. So I'm just going to substitute that into the original equation. So when x equals 2, y is equal to -4. So we found the local minimum. So the graph should look something like this. And there is our graph.